The first one says 2 over 3 plus 1 over 2. Um, if we consider 3 and 2 at the bottom, we'll discover that they are not the same denominator, right?
Yes.
Good. So what we need to do here is that we will say the bigger one, is it a multiple of the smaller one? Yeah, it's
Yeah.
not. It's not. So definitely we'll keep checking the next multiple. The next multiple is 6. And this 6 is also a multiple of the smaller one, right?
Yeah.
So that means you are right by picking 6 because I can see you already picked 6 as the common denominator. So now, if you now say how many 3 is in 6, that is 2. Then 2 times the 2 that is at the top, that gives 4, right? Right?
Okay.
Then
Yeah.
how many 2 is in 3? I mean, is in 6, that is 3. Then 3 times the 1 at the top, that is 3, right?
Yeah.
Wait, let me do that again because I think you added the number at the bottom or something in that number 1. Hmm?
It was because that I think it was because that um I thought it was because that
It
that
was, yeah. So, but let me
two threes going to six and two three and three twos going to six. I guess
Okay, you didn't multiply with the one above, right?
yes.
Oh, that's that's probably the mistake, okay?
Okay.
If you remember vividly the other time, I multiplied them, okay?
Okay.
I multiplied them. So with that, whenever let me start that place again. Okay.
Okay.
Now at least you understood how we got the common denominator, right?
Yes.
Good. So now say how many threes are here? That's 2. Then the 2 multiplied by the number at the top. That'll give me 4. Okay. Is that clear? Good. Then plus this one. How many twos are here? That's 3. The 3 times the number at the top. That is 3. Okay.
Okay.
So 4 plus 3 is what? 7 over 6. But we cannot leave our answer like this, okay?
Okay.
So it's equal to what? One whole number, 1 over 6, right?
Yes.
One whole number, 1 over 6. So do you understand that first one?
Yes.
Good, good. Let us look at the second one. So if that is the method you have used for everything, it might not be correct, okay?
Okay.
So let me do about 4 and be sure that you understand them very well. Then I will now ask you to do maybe another 4, okay?
Okay.
So can you explain number 1 to me now so that I can be sure you understand what I'm saying?
So one number one. So so because the because the denominators are not the same,
Okay.
we have to um find
A common denominator, right?
yes.
Then we'll check the bigger one. Can the bigger one Is it a multiple of the smaller one? If yes, we will pick it. But if no, we'll look for the next multiple of the bigger one, right?
Yes.
Okay, good. So with that, we have um, 3. The next multiple of 3 is 6. So 6 is now a multiple of 2, and we pick the 6, right?
Yeah.
So after picking the 6, where did the 4 and the 3 at the top, where did they come from?
It was because that 2 times 2 is 4.
Yeah,
And
where did we
3
get
times
2?
2
Where did we get 2? We got 2 from 3's in 6. That's 2, right? Then we
Yes.
now multiply it by the 2 that's above. It gave us 4. Then 2's in 6. That's 3. Then 3 times the 1 gives us 3. Okay, and that's where we got 7 over. Do you understand how I change it to mixed number?
Yes.
Okay, good. Let's check the second one. Maybe this. The denominators are not the same. So the bigger one is 10. Fortunately, it's a multiple of the smaller one. Okay,
Okay.
so we use it. Then we say, how many 5 is here? That's 2, right?
Yes.
Then 2 times the 2 at the top. That'll give us what? That'll give us 4, right?
Yes.
Plus, how many 10 is in 10?
1.
That's 1. Then 1 times the 1 that's at the top. That's 1, right?
Yes.
So I now have 4 plus 1 giving me what?
5.
Over what?
0 10.
Okay, so what will be
It's
my
just the
final answer?
same like 1, 2,
Very good.
1 over 2.
Very good. Now you understand it, right? But
Yes.
I'm going to do 2 more or 3 more. Then you do the remaining as, or let me just do 6 so that I can be sure you get the remaining 4 by yourself. Okay.
Okay.
Now let's go to the next one. What should be our LCM? Can we pick the bigger number? No.
No.
So the next multiple is 10. Can 10 work for us? No. The next multiple is 15. Can 15 work for us? No, because it's not a multiple of 4. So the next multiple is 20. Can 20 work for us?
Yes.
Yes, because it's also a multiple of 4. So how many 5 is in 20? That's 4, right?
4.
Then 4 times 1
Yeah.
is what? 4.
4.
Then plus, how many 4s are in 20? That's 5. Okay. Then 5 times
Okay.
2 is what? 10.
10.
So this will be 14 over what? 20. And we can
20.
reduce it to the lowest term to be 7 over what?
So 7 over 10.
That's good. That's correct. So now let's look at the next one. The LCM cannot be 8, though they are not the same, so it can be 8. If we keep checking multiples of 8, the next multiple is 16. 5 cannot divide 16 because 8 is not a multiple, 16 is not a multiple of 5. The next multiple is 24. 24 cannot work. The next multiple is 30. No, not 30, 32. Okay, so 32 cannot work. While the next multiple of 8 will be what? 40. So 40 can work because it's also a multiple of 5. So we pick 40. So it looks as if we just said 8 times 5, 40. Is that clear?
Okay.
And this one looks as if we said 5 times 4 is 20. Okay. And the first one looks as if we said 3 times 2 is 6. Okay.
Okay.
But you know this one, we did not say 5 times 10, right?
Yes.
Because 10 is already a number that we can use. Okay.
Okay. sir.
Good. So don't just always multiply. Just follow that method, okay?
Okay.
Good. Because at times you might not need to, like if I have another fraction, let's assume I have something like um 1 over 3 plus let's say this is 3, 3, 3. Okay, so let me use 1 over 3. Let me use something like 2 over 8, okay, plus 7 over 12. Now, you can see that the bigger one, 12, right?
Yeah.
Okay, instead of
Yes.
putting 2 at the top, I want to change the number at the top to 3 so that it can be a fraction that will not be reduced. So 3. Now, the bigger one is 12, but we can't use 12, right?
Yes.
If we say 8 times 12, it will give us a big number. Is that clear?
96.
Yeah, it will give us a big number, 96,
Okay.
but we don't have to use 96, okay?
Okay.
Yeah, we don't have to use the 96. So, in order to know what we are to use, we'll follow that method, okay? So, let us keep checking the multiples of the bigger number. The bigger number is 12. So, the next multiple is 24, right?
Yeah.
Can 24 work for us? Yes,
Yeah.
because 24 is also a multiple of 8, right?
Yeah.
Good. Now you can see we don't need to use this 96, right? So that is the
Yes.
essence of understanding the principle. So how many 8 is in 24? That's 3. 3 times 3 at the top. That gives us 9, right?
Yes.
Then how many 12 is in 24? That's 2. 2 times the 7 at the top is what? 14, right?
40.
So what is 9
Yes.
plus 14? That's 23, okay?
22.
Good.
Uh,
Over 24. So this will become our answer. So we cannot just conclude and say we should be multiplying, okay?
okay.
But in the case of numbers that, like this 4 and 3, I can just multiply straight away and say 12 because there will not be any number smaller than 12. But the question we should ask ourselves is this: what if we use 96? What will be our difference? Let us try and use 96, okay?
Okay.
We will have to say how many 8 is in 96? That's going to be 12,
12.
right? Yeah, good.
Yeah.
So that 12 times 3 will give us 36, okay? Plus, how many 12 in 96? That's 8. 8 times 7 will give us what? 56. So we'll have to add 56 and 36.
98.
98. Is it 98 or 92? 6 plus 6 is 12.
92.
92. So we'll get 92 over 20 over 96, right?
Yes.
So the only difference is that we only need to change this back to this place, okay?
Okay.
So we can cut it down with 2. How many 2 is in 9? That's 4. How many 2 is in 12? That's 6. Then how many 2 in 9 again? That's 4. 2 in 16? That's 8. Then if we cut with 2 again, we'll say how many 2 in 46? That's what? 23.
22.
Then 2 here, 24. So you can see this one is taking us a longer step. That's why we must use the lowest common multiple. Okay?
Okay.
That's why we must use the lowest common multiple. So now let's continue to. I believe you're getting it right.
Yeah.
So let's continue. How many 5 is in 40? That's 8. 8 times 3 is what? 24. How many 8 in 40? That's 5. 5 times 3 is what? 15. So what is 24 plus 15? That's 39, right?
Yes.
So our answer is 39 over 40, and it's already in proper fraction, so we don't need to change anything. Then the next one, 7 and 4. If we say 7 times 4, that would be what? 28. But,
28.
but we will not need to use 28. Let's just check multiple of 7. The next multiple is 14, right?
Yes.
Okay, we'll still need to use 28 because 14 cannot work. And 21 will not work. It's not a multiple of 4, so that will be 28, okay?
Okay, sir.
Then, how many 7 in 28? That's 4. 4 times 2, that's 8. Plus, how many 4 in 28? That's 7. 7 times 1 is 7. So this is going to be 15 over what? 28.
28.
Do you understand it?
Yes, sir.
So I'm doing one more, which is subtraction. Then I'm going to change some of them to addition for you so that you can have both addition and subtraction, okay?
Okay.
So now let me do this number 6. If it's subtraction, it's still the same method. So the LCM should be 10, yes or no?
Yeah.
So how many 5 is in 10? That's 2. 2 times 3, that's 6, okay? Then
Okay.
minus 10 in 10 is 1. 1 times 3, that's 3. So 6 minus 3 is 3 over what? 10.
10.
Is that clear?
Yes, sir.
Now I'll give you some time to put down the solution to number 1 to 6. Then you will do number 7 to 10, okay?
Oh,
So you do number 7 to 10 as classwork now. So once you are through, you let me know, okay?
okay.